In 4.4, we're going to put everything together that we've been doing up until this point. We're going to use all our properties of logarithms, our properties of exponentials. We're going to kind of play around with some stuff. So really, the bulk of this lesson is not procedures and processes. It's different problems you're going to encounter and giving you approaches on how to solve them. If you struggle with any of the homework after viewing the lecture and working through them, then just send me a Canvas message. I'll be happy to help you out with some individual questions. So the first thing I want to do is I did kind of break it down into a couple sections to give you some hints and tips of things you might choose to use to help you out. If you have a logarithm on one side, such as log equal to something, consider turning the equation into an exponential equation, such as doing our Snell method. And there's another quicker way that we can do it by exponentiating both sides to the same base. So I am going to do something a little bit different here, but it's applying that Snell method and turning it around. So your Snell method says that you go from 4, change this log into an exponent. So 4 to the third is equal to 2x minus 6. But I want to show you a shortcut instead of going from logs to an exponential of applying your inverse property to help you with it. So we learned in previous sections that the base of 4 is here, and that was my exponent on a base of 4, that these essentially cancel by that inverse property. And this is a quick way in order to convert it back to an exponential. So if I want to do 4 making this the power, I just still have to do it to the other side as well. Because remember, basic rules of algebra, whatever you do to one side, you have to do to the other. So over here, it applies my inverse property. I'm left with 2x minus 6 equal to 4 to the third. But again, doing your Snell method, doing 4, coming around, also gives you 4 to the third equal to this. Now, I'm just solving for x. This gives me 2x minus 6 equal to 4 cubed, which is 64. I'm going to solve for that x. So I'm going to add 6. Let's see, that gives me 2x equal to 70 and divide by 2. So x is equal to 35. So with this one, I used my inverse property, or I could have used it as turning it back to an exponential and then just solving for x. What you're going to find as we work through this section, the way I work it out, the way the help videos work it out, or maybe you have a study partner, the way they work it out, may be different. But as long as you're doing all the properties mathematically correct, you're going to still get it right. So let's work this one. Based off what we did in previous sections, when you have a log minus a log, we can condense this. Remember, subtraction is actually division. So I can put this together as log of 50x plus 25 all over x equal to 2, which makes my life simpler because now I can either apply that inverse property or I can Snell it around. If you like, I'll do that this time. This is an assumed base 10, so I could bring this around. This gives me 10 squared equal to this large fraction here. Don't let a problem overwhelm you. Think about what little steps you can do and start executing from there. So now to get rid of this division, I could multiply both sides times x. Instead of doing 10 squared, I'm going to call that 100 times x equal to, these x would cancel, leaving me with 50x plus 25. Solving for x, I subtract the 50x to move it over. So it gives me 50x equal to 25, and then divide both sides. So x would be equal to 1/2. So this one was changing, using that property, going from a log to an exponential. Let me start this one out again and show you how using that inverse property is also super handy. This is kind of the neat thing about logs, is the fact that you can use so many different approaches and apply the properties, and they're very malleable in how you can work with these different logs. So again, first thing I'm going to do is I'm going to put it together. So I'm going to say log of 50x plus 25 all over x. So I definitely still need to condense it first. Then, since this is an assumed base 10, what I can do is I can raise both sides to the power of 10. This would cancel by that inverse property, leaving me with 50x plus 25 over x equal to 10 squared. And then you see we're right back to this step. So whichever method makes more sense to you, either going from a log to an exponential or using this inverse property, then apply that either way. Either way, we get to this same step and we can solve for x. Now, if you haven't done any of the homework in 4.1 to 4.3, that needs to be your starting point, because none of this is going to make sense if you're not proficient with those first 3 sections. Let's do some more. It's all about examples in this section. Next one says solve the equation. I got a lot going on in there. So the first thing that I'm going to do is I'm going to try and get my logarithm by itself so I can apply some of the stuff we just did. So I'm simply just going to subtract 5. So it gives me 4 ln of 5x equal to negative 3. Then I'm going to get rid of this 4, so I'm going to divide both sides by 4. So it gives me ln of 5x equal to negative 3/4. Now that I'm to this step, I need to do something in order to get rid of that ln. Again, we can either rewrite this as an exponential. This is base e, so I can swing it around and get my exponential there. Or let me use that inverse property again. New use of it, so let's keep trying it. The inverse of ln is e, so if I raise this e to the power of this, as long as I do it to the other side, it's equivalent. E ln's cancel. It gives me 5x equal to e to the negative 3/4. Now to get x by itself, I just divide by 5. So x would be equal to, depending on how the question is worded, if it tells you how to round, you do want to go to your calculator. So I'm going to say e to the negative 3/4, so negative 3 divided by 4, and make sure that that's all in parentheses, enter. Divide it by 5, enter. And then I get my decimal, and make sure you round to the approximate number of decimal places they would like. I like 3 decimal places, so 0.094. So again, this is just solving for e. This is your inverse property, and this was just algebra moving it around so I get log by itself. So that's one type of problem you're going to encounter. Part B says, if you have exponential expressions on one side, turn the equation into a logarithm by taking the log of both sides. So again, it's that converting from exponentials to logs or logs to exponential, but I want to show you some shortcuts using our inverse property to help us. First thing I would do is I want to isolate that exponential. So I'm going to divide both sides by 3. This gives me 2 to the x equal to 42 over 3. Just grab my calculator. 42 divided by 3. So that gives me 14. Now, you can either rewrite this as an exponential, or let me show you how the inverse property can help me with this. What I'm going to do is I'm going to go ahead and use a log to help me with this. My favorite log to use is ln, but any log would work. I'm going to ln both sides. The reason I want to ln both sides is because now, looking at it in terms of logarithms, I can use my properties of logs, the fact that a power can come out front. So it gives me x ln 2 equal to ln 14. So in order to get x by itself, I would just divide by ln 2. So x is equal to whatever ln 14 over ln 2 is. So I'm going to come over here to my calculator and I'm going to do it slow. I'm going to do ln of 14, enter, get my answer in there, divide it by ln of 2, enter, and get my answer there. So it gives me 3.807. Now this is just one way to solve this. I want to go ahead and start here from this step with that 2 to the x equal to 14 and take a different approach. Let me show you maybe a different approach. Maybe this kind of confused you. You're like, hey teacher, you said I could turn that back into log. That's what I want to do. So I'm going to say log, we're going to do the Snell method again. Log base 2 of 14 is equal to x. All right, I got x by itself. But my calculator won't do log base 2 of 14. So now we have to go back to our change of base formula. And so I'm going to say log of 14 divided by log of 2. But look, ln of 14 divided by ln of 2. This is all the same process because remember we could either use base 10 or base e. And so this still gives you 3.807. Either approach gets you there. Work with what you feel most familiar, applying properties correctly. But I want it to expose you to this way to give you another outlet or another tool to get you going. Let's just keep working sample problems here. Solve the equation. Oh goodness, what are we going to do with this? Well, the first thing I'm going to do is I'm going to get that exponential by itself. So I'm going to minus the 5 to move it over. This gives me e to the x equal to 55. Now what I'm going to do is I'm going to use that inverse property on this one. To get rid of an e, I would need to ln. So if I ln both sides, I get ln e, which I've talked about as line, and that would cancel. So I get x equal to ln of 55. And then again, if you go to your calculator and do ln of 55, you get your decimal, 0.4007. Again, another approach. With that e to the x equal to 55. Maybe you said, well, I would have just snailed that around. So that would give you log base e of 55 equal to x. Well, log base e we rewrite as ln of 55. And notice I'm back to the same step. So either approach works with this one. I just like ln in both sides. I think that goes really quickly. Let's look at this one. Uh-oh. Adding more stuff into it. Same concept. I still want to get just the exponential by itself. So I'm going to add 4 to both sides. So it gives me 3 times 3 to the 2t minus 5 equal to 15. So I'm going to divide both sides by 3. 3 to the 2t minus 5 is equal to 5. Now I got that exponential by itself. I really like working with my ln in order to work with that. So I just ln both sides. So it gives me ln of 3 to the 2t minus 5 equal to ln 5. The benefits of logging both sides like this is I can now use my power rule and bring that out front to give me 2t minus 5 times ln 3 equal to ln 5. Now your goal is to get this t by itself, so I'm just going to slowly move things away from it. So I'm going to divide both sides by ln 3. So I get 2t minus 5 equal to ln 5 over ln 3. It's going to be a decimal number, so I'm going to kind of float it along for a little bit, and then I'm going to show you on the calculator how to get that exact answer. So I would have to add 5 to both sides, so I get 2t equal to ln 5, ln 3 plus 5, whatever that number is, I'm going to add 5 to it, and divide by 2. So let me grab my calculator, and let's show how we're going to do this. So first thing I'm going to do is I want to figure out this number here. So I'm going to say ln of 5, enter, divide it by ln of 3. So that's this number right here. Then I want to add 5 to it. So I'm going to say answer plus 5, and it gives me whatever this number is. Then I'm going to take whatever that number is and divide it by 2. So divide it by 2. That gives me 3.232. Now I did not want to type in ln 5 divided by ln 3 and round that answer. What if I rounded it to 1.46? 1.46. Or even you round it to 1.5. 1.5 plus 5. Then you divide it by 2. You can see I'm going to be off by the hundredths place, and in this case, even the thousandths place. So be careful. Don't round until you get to the very end of your problem. Kind of work with it and just go slow. Don't let a problem like this overwhelm you. Take small steps. Figure out what you can do. Get there. And if you need help, contact me. I'll be happy to help you. Maybe send me a picture. Grab your phone, take a picture. Hey, this is where I got stuck. What could I do next? This section is all about applying what properties you could and could not work with and manipulating, kind of going from there. So logs can be really interesting, do really neat stuff with them. With this one, I look at it and I go, that kind of looks like a quadratic. I got like a squared term, I got a variable, I got a constant. So you know what? I'm going to factor that thing. Everyone's fun favorite thing to do on a Friday, factor, right? What would multiply to give me e to the 2x? That would be e to the x times e to the x. Because notice, e to the x times e to the x, whenever the bases are the same and you're multiplying, you add these exponents. So x plus x gives you a 2x. So that's what would multiply to give me e to the 2x. I think what would multiply to give me negative 3 and add to give me negative 2 would be a negative 3 and a positive 1. Now that I have something times something to give me 0, I'm going to solve that. E to the x minus 3 is equal to 0, and e to the x plus 1 is equal to 0. I'm going to solve both of these out. So I say e to the x, that'd be equal to 3 by adding that 3 over. But I got to solve for x. So now I'm going to have to pull in some of those properties. So I'm going to ln both sides. ln e looks like line, so I put a line through it. That gives me x equal to ln 3. So then x would be equal to, grab your calculator, ln 3. So 1.099. But e to the x plus 1, I'm going to solve that. So I subtract 1 from both sides, I get negative 1. We looked at this in the very first section. My exponential, because of the basis of its range, is never going to be a negative number. So this one is not going to work out. Although factoring wise, it did factor, solving wise, that negative is not going to work out for us. So the only answer is 1.099. I really like that problem. It's something you may see on your exam because it pulls in your factoring now with your properties. So a problem where I can test you on multiple concepts really takes it to see, are you just getting the basics or can you take it to a higher level? This next problem is probably the hardest problem on our lecture, but it's so interesting, I wanted to work it with you. So with this one, my problem is I have two different bases, and I can't set two different bases. I can't just circle the exponents and solve from there. So I'm going to use some properties. In order to get these x's out of the exponent, if it were a log, I could move those out front. So I'm going to ln both sides. This gives me ln 7 to the 3x minus 7 equal to ln 9 to the 7x minus 5. The benefits of using log is now you can use your power rule and you can pull those out front. So that would give me 3x minus 7 times ln 7 equal to 7x minus 5 times ln 9. So the issue with this is now I need to get x by itself, but it's being multiplied by these. Like I can't really maneuver that very well. So just like this is a number, because ln 7 is a number, I'm going to distribute that to get rid of my parentheses. I'm going to do the same thing on the left. So it gives me 3x times ln 7 minus 7 times ln 7. No matter how crazy it looks, we're in college level math now. We're doing harder stuff than high school. We're just going to keep doing and applying what we know. So 7x times this is 7x ln 9 minus 5 times ln 9. Again, as scary as it looks, just keep doing what you know. You know that you need to get x's together. So I'm going to move all my x's over here to the left. So I'm going to have to subtract this one to move it over. So I get 3x ln 7 minus 7x ln 9. And I'm going to move this one over here to the right side because it doesn't have an x on it. So I'm going to have to add it to move it over. Adding it to move it over, I can't combine this together because these aren't the same ln. So I can't just do, oh, that's 2. I'm just going to write it out. So I have 7 ln 7 minus 5 ln 9. And then I notice these both have an x, but I can't put it all together, so I'm going to factor an x out. 3 ln 7 minus 7 ln 9 equal to everything over here. And then to get x by itself, I have x times something. I just have to divide by that something. Now don't stop. Don't give up and say, life is hard. I hate that problem. I don't ever want to do it. This is my final answer. As crazy as it looks, as much as you may not like it, that would be my final answer. Now, if it's set to 3 decimal places, I can go play with my calculator and find all this. But putting all this together, I had to LN so I could use that power rule and bring it out front. Then it was just a matter of distributing and moving things all the way around. Now, this is not going to be like, I'm not going to give you 20 problems like this on your homework, but I do expose you to higher content. We're not just going to do baby problems. And we've talked about this before. You don't just get 2s and 4s for all your answers. But I want to show you how log properties are really nice in order to work harder problems that the bases weren't the same. It wasn't just an answer of 2s and 4s. So I want to work a problem like this with you to expose you to some other stuff, but at the end of the day, when you're working through this section, make sure you apply all your properties, go slow, show each step as you go, and if you need any help, contact me along the way. Now don't wait till an hour before it's due at 11 o'clock at night and message me. You may not get a response to the next day. But work on it early, work slowly, and you can do this. So I hope it goes well with 4.4. It's definitely a culmination of everything we've been doing so far.